Okay, good afternoon, everyone. Welcome to the first this kind of session. And let me give brief introduction about why we thought of doing this kind of session and the objective of this session. So basically, why we thought of doing this session is actually we noticed that there are a lot of basic things or basic mistakes that we are doing again and again, where we already learn in hard ways, right? So as junior guys, we are still doing same mistakes. So main objective is to share that knowledge and prevent that you guys are doing those basic mistakes and learn from the mistakes that we have done and continue from there, because you don't have to reinvent the wheel. So that's the main objective. And this is going to be a mainly a practical session. We'll cover a little bit of theory and thereafter mainly the practical sessions. So use this time to check. Okay, so basically use this particular 3 hours to ask questions and learn from those things, right? So from presentations and exercises that we are planning to do, we might not cover everything. So if you have any question, feel free to ask questions and learn. And Sajeev also here, and he will also help. Also in this session, we are not going to cover some of the basics like normalization, those kind of stuff. We are not going to cover those areas. Basically, we are planning to cover basic fundamentals about how RDBMS system works. Now, then why we choose an RDBMS? So now there are so many database systems out there. So why we have selected RDBMS? Again, you guys also can answer, right? So if you think of the systems that you have worked, how many systems that we are using other database technology than RDBMS system? In cake, can someone answer how many systems that we have, and out of those many systems, how many non-RDBMS databases that we have? I would say we have around, yeah. Another? Yeah. Post we have menu and shop. Yeah. Only handful, right? So we have around, correct me if I'm wrong, Sajid, we have around 40 databases, right? Out of those 40 databases, only 3 databases or 3 or 4 are NoSQL databases. Everything else are RDBMS, right? If you think of any system, any enterprise system, majority of them are RDBMS, right? It's still the fundamentals are. That's why we thought of doing RDBMS system. Cover this topic because 9% of the time we will be using RDBMS. Then why we thought of doing database things first, right? So if you think of a software development life cycle or your journey or during your career, how many times that you have changed a database? Right. So someone from Anand, how many times that you have changed a database? From your experience, many times, but in general, if you think of POS, yeah. So if you think of POS, we have started our POS system around 2011, right? We still have our leap set database, whereas we have written POS couple of times, right? If you think something wrong in the logic or architecture kind of mistake, we can throw that code away and rewrite. But we still have the database. Why is that? Because it is very difficult to change, and all the data that you captured over the time, it's going to stay there. So it's very important to understand how a database works and what are the problems that you will have to face over the time, because otherwise it will be a time bomb, right? You don't know it will work for like couple of years, but afterward when it grows, it will fail, right? That's why it's very, very important as a software engineer or developer, you need to understand how a database system works, and especially RDBMS, because 99% of the time you will be using RDBMS. So let's move into the session then. So during today's session, this is the agenda that we are going to cover. And first, we'll cover very basic stuff about few theories about how RDBMS system works. Then we'll really jump into the exercise. We'll be spending a lot of time on exercises, and we want you to do that exercise at this moment and learn the issues and learn from the mistakes, and you might learn from errors and all. So during that time, you may ask questions and fix them. Right? That's the expectation. First two exercises, actually, we will be looking at certain best practices that we have to follow and certain fundamentals, how RDBMS works in terms of queries and all. And third exercise, and that is, we'll touch upon briefly based on the general needs that we thought of better to cover about ETL writing and certain areas that you have to aware of ETL writing, because that is also a kind of important area. Okay. Any question up to this point? Okay. So this is going to be an interactive session. I'll be asking questions as well. So feel free to answer. So any idea how a query getting executed in a database system? Let's say you log into a system and run select all from a table. What happens from there onwards? Any thought? Anyone know what's happened from there? Someone? Pasan? What's the execution flow? Okay, somewhat correct. And any other different answer? Somewhat correct in this, it's actually correct. You have explained sub part of the process. So any other answer? I just want to know the flow. What happens once you hit a query to a database? What happens? First what happens, then and then. Yeah, that is actually, I would say 90% of correct answer. So basically, this will happen, right? So first, it will go through a parser, right? I don't have to explain what's happening through parser, because you can see what's happening. If it is statistically wrong, you will get an error, right? If it passed from there, it goes to the next step, right? Which is actually the query optimizer, which actually Pasan explained, as well as Dham, right? Where it analyzes a lot of factors. You might run select all from table, where whatever, right? But it doesn't go and execute that query directly. It's analyze all the factors and identify what is the best way of executing this query, right? There can be different indexes, there can be different tables that we have to join, what are the different data types and all. So first, it does all these analysis, and it came up with something called query plan, where it thinks this is the best way that query can be executed. So in general, this is the actually we'll be doing exercises based on MySQL, but in general, almost all the RDBMS system works like this, right? So first it goes to the optimizer and identify the best way of executing a query. Then it goes to the execution engine, right? So where it actually reads the data from disk or whatever the storage media and prepare the result set and give it to the client. Like that is where actually you decide how you store data, what are the data types, and whatever. So it is very, very important to understand what's going on each and every section, and almost all database systems provide certain tools and mechanisms to see how query goes through each and every process. So because every step is important to get an understanding about how this query performs. Right? For example, in case of MySQL, what's going on in the optimizer, how it's going to be executed. Those information that you can get from the explain command, right? Then rest of the stuff, how it's being executed, what are the tables, what are the steps has been followed, the time taken for each step, and everything, you can get it from query profiling, right? Let's see. Let's run a simple query and see how it works. Hope you also have the database installed. I think if that is the case, you can also try it out. So, you can't see, right? Can you see that? So now in this database we have a couple of tables. Let's run a query and see. Let's say, you can use \capital G and see the legal view of this. So basically, this gives about information like the what is the type of select, if there are any indexes we use, let's say, let's try a different way. So now this gives some details about what is the select type, the table name, if there are possible indexes that can be applied, and more importantly, this field, how many records is being analyzed to fulfill this particular request. Right? In this case, to fulfill this particular request, it has analyzed about kind of 500,000 records. Right? So it's kind of a large number. Then this is actually what's happening inside the optimizer. Right? If we execute the query, this is the way it's going to give the information to the execution engine, how we are going to execute the query and how it should be executed. Now, to see what's happened within the execution engine, there's something called query profiling. So first we have to enable query profiling and run the query. So to do that in MySQL, we can there's a command called set profiling equal 1. So now the profiling is enabled. Now what you have to do is, you just have to execute the query as in the normal way. So it will pass through all these steps, and it will take some time. And now you got the result. Now the profile has been created. Now it has recorded how this query is executed in the database. To see this database, the information, now you can even run multiple queries now. You have enabled profile, everything will be recorded. Now to see these things, there's a command called show profile. So this, now since we have run only one query after enabling profiling, you can see this is the query that we have executed, and this is the total duration that it took, and the query ID. Now to see the detail of this query, you can run show profile for query 1, which gives you the particular profile for the query. So this gives you time taken. There's a way that we can get detailed view as well, but I'm not going to explain those things. This particular view gives you the information about the time taken on each and every step. For example, so if you, to fulfill that particular request, there are so many steps it's going through internally, right? First it's starting, then it checks for the permission, whether this particular user has permission to run or access these tables and nodes. Right? It checks. If the permission is there, then it has to open the table, which means the actual data files. It has to read them. Then it requests, now there's a locking mechanism, two types of locks, right? If it is select, you get a share lock. If it is an update, you get a kind of exclusive lock. So according to the query, you have to acquire a lock. It also takes time. Then it goes to the optimizer, which Pasan and Dam said. It identifies what are the metadata, what is the way of, what is the best way of running the query. Then analyze so many other steps. Then more important part is the one it has taken more time, which is sending data. That entire section gives information about how long it took to execute or read the data from the disk, right? All these operations, it has to access hard disk, memory calculator, whatever the stuff, it's going inside there, right? If you look at 99% of the time, or 99%, 99 times of the time, a query takes more time on this particular section. Because that's the hardest part and that is the slowest part. Because if you have to access hard disk, since you have learned computer engineering, hard disk is the slowest storage media, right? Whenever you try to access hard disk, it takes time, right? That's why it takes longer time, right? So these two commands that you can use to identify, if you get a slow query, to identify where the problem is and optimize those things, right? These two factors that you have to consider hands in hand. To do that, you have to have good understanding of how the database is stored and how the database system works, right? Are you clear up to this point? Any question up to this point? Were everyone able to try these commands with the query? If you have any question, you can feel free to ask. Right? So these are two commands that you can use on MySQL, but almost all the database systems provide some kind of tools to get same information. Right? Not necessarily the same set of commands, same keywords. Right? Clear? Time taken to get a look, right? There can be situations where it has to wait because of the concurrency. So in that case, those times will take longer, right? That's why now, when you execute a query in a production system, also you can keep this enabled, right? If you come across slow queries, you can analyze the profile and what has happened there, where it's got stuck, whether it's execution time or the optimizing time or the locking time. So those information you can get it from there. So you can narrow down where the problem is, right? That's why this is very important. And so in this case, each and every step, what is the time taken to execute that particular step? So total time will be the sum of this one. That is the total time which is taken to execute this particular query, right? Yeah, because this again records data, which means it requires again I/O and again certain other server resources. Normally, unless it is really, we don't enable it. But there are options that we can limit number of profiles that we can keep, and there are settings that we can optimize that as well. But generally, we don't enable profiling in a production system due to the additional resource requirements for these things. Right. Okay. Let's move into the presentation. Okay. So now let's look at how the data is stored in a RDBMS system. Right. So basically, any RDBMS system, data is stored in something called page file. That is the basic unit of the storage, right? What does this page file means? This is actually a fixed size, let's say, portion of file or whatever. Basically, let's say one hard disk seek can read a particular page at a time. Right? Let's say if you have to read 1,000 page files, which means there are 1,000 hard disk access or hard disk seeks, right? So this is the atomic unit that database system can access, right? So all the data, regardless of the type, whether it can be an index, it can be a data file, it can be a image or whatever. If we store them in a database, those are stored in page files. That's the basic. And more importantly, those are fixed size. Most of the database systems is server level configuration. What is your page file size, right? In if you think of MySQL, it can go up to 16 kilobyte, but by default is 16 kilobyte page file, right? So which means at a disk seek you can read only 16 kilobyte of data, right? Within this page file there are so many other metadata plus your rows as well, data rows, right? So in case of MySQL and most of the cases, rows has first row has a link to the second row, so that if you start accessing from some point, you can link to the next record, right? Likewise, all the page files also has a link to the previous page and the next page, which means actual linked list. If you start accessing from some point, you can go forward or backward from that point onward. You don't have to randomly access. But this is the fundamental unit that you can kind of store data and read, right? Yeah. So queries you don't have control over. These will be used with the queries. What are the queries that we are writing? For example, if you are running a let's say well-indexed database, you are running a kind of range query, right? Then you have to know only about start point and end point. You don't have to access each and every page through the index. Once you know the start point, you can traverse through the pages till it finds the end point. You don't have to traverse back and forth through the index pages. Right? We'll come into that part, how the indexes are works, and I'll cover that part as well, how these index files are also stored. Right? So basically, this is fundamental unit. It's service type and it can be configured per service. For example, it doesn't have any relationship with the machine or the operating system. This is completely controlled by the database management system, where you can configure my page file size. In case of MySQL, default page file size is 16 kilobyte, which means whatever the data, it's one time server level configure. You can even change, but as I know, some database systems even support table level configuration as well. This table can have 16 or 64 byte page files as well. No. Yes, you can change it. You can change it. Then it takes a lot of time to rearrange all the data. Right? So, but you cannot have a table or database. Subset of page files are 16 kilobytes, whereas subset of page files are 64 kilobytes. Right? It's unified. It will rearrange all the data. So, why this is important? Right? This is important. You might design a huge table. Right, this hundreds of columns, right? So now one more thing I forgot to mention. If you think of a row cannot store in 2 page files, right? A particular row should stay within a page file. In MySQL, there's a limitation. On a page file, you should have at least 2 rows, right? What does that means is, your row has a limit. Number of columns and data has a limit. In case of MySQL, it is less than 8 kilobyte. You have to, if it exceeds more than that, you will simply get a error saying that you cannot create this. Let's see an example as well. What happens? So you cannot create more than that. This is actually maximum size that you can have a column. In this case, it's about 21,845, which is kind of in MySQL. You can for data storage you can utilize just more than 50% of the page file, which means if you have 16 KB page file, you can use somewhere around 12 or 10 kilobytes to store data. Out of that, since there's a limitation or restriction, you have to have kind of 2 rows in a page file. It's again for a particular row, you have to have somewhere around 5 to 6 kilobytes. Right? So that is the maximum length that you can have for a column, or it's kind of total length of the table, a particular row. You might have 10 columns with 2 kilobyte field, or 2 columns with 5 kilo or 2.5 kilobytes, something like that. Right? It decide at the end the constraint is the size of the page file. So what will happen is, if you design the table in kind of poorly, for the sake of having data types, you might have all these fields in big ints, right? You might have all varchar 255 columns or char 100 columns, since it supports. What will happen is, eventually you will be able to store low number of rows in a page file, right? Which means if you have to run a huge query, you have to read thousands of page files to fulfill that particular request, which means thousands of disk IOs, which is slow. Right? That is where you get lot of performance issues, right? Which we don't think when we are designing a table, since from the beginning we don't get those issues. We just put whatever the largest data types that we have at that time. If it is int, we will allocate int 10 digits of 11 int, which we don't need. Maybe we might be using it to store an status 1 or 2 or 3, maybe less than 10 digits, right? Still we allocate 4-byte integer, whereas there is an option where we can allocate number of bytes int 2, int 1, something like that, right? We don't use them because we don't think in that angle, right? If we do that, we can embed lot of rows into a single page file, which means in a single disk IO we can read lot of data into the memory. Right? We have to think in that way as well. Okay, clear? Any questions? Clear? Okay. So any question up to this point? Okay. So now this is how those page files are stored. So normally you will have a set of rows in a page file, then the next page file, and each page file has a link to the previous page and the next page. So if you start from some point, you can traverse through the page files and read there. So let's see what will happen if we run a query like this on a table where we don't have an index, right? So where we can start, right? Obviously, it has to start from the first page, right? There's no other way that we can know where to start, right? What it does is, it starts from the first page, then it reads through all the records in that page file. See whether it tallies the record, right? If not, it goes to the next page file, right? Then it reads through all the records in that page file as well. Then it's move on and up until it finds the record, right? Clear, right? If there's no index, right? So which is not a good thing, right? I mean, if you run a program, you will scan whatever you have to find that particular record, right? If you have 1 billion or 2 billion records in a database, it will take years to fulfill that particular request, right? That's where we have something called indexes, right? Indexes actually optimize the way that we are finding out these records. When you are talking about indexes, any RDBMS system, there are 2 types of indexes. First thing is clustered index, and the second one is non-clustered index, right? In other words, what you know is primary key and secondary indexes, right? There's a big difference of how, in terms of how the data is stored in terms of those 2 types of indexes, right? Let's see how it goes. So now, in case of primary key, the difference is all the data files as well are arranged or sorted based on the primary key. For example, if you have an integer number, I don't think you can see. Now, assume this is first column is ID and it has kind of numbers, right? So, all the data files also, as soon as you add a primary key, data files also got sort of first page file will have the lowest number of records. Second page file will have second, something like that. And you will have a B plus tree for the index, right? What will have is first index this part, what we call root node, where it has links to the all secondary index page file. Basically, what it has is the next page. What's the starting point, right? All the records larger than this number are contained in this page, right? Whatever the records larger than this one is there, right? Something like the secondary level also has all the pages, all the records larger than, let's say, 1000 are in page 1. 1500 are on page 2. Something like that, linked to the page. Right? So, if you run this kind of query, where you have an index, first its access is, it goes to the optimizer and it sees, now there's an index like this. I can use that index to fulfill this particular record. Then it use root, first it use the access from the root node of the index and find out where I can access to find this particular record, right? So it reads from the beginning and it's again similar to the normal page file, and see it's in the first page because it's obviously less than 100 or 1 million, and it should be in the first index page file. Then it goes to the second index page file, right? So then it does the same and find out where it is, and it identifies it's in the page file 10 and goes to that page file and find out that. So if you look at, in this case, up to, let's say, 2 million records, its depth is 2. You just have to read 3 page files to understand, find out that particular record, right? So likewise, it is kind of, it matters only the depth, right? How many page files that we have to read, right? When the table is closed, again depth also going high. So when you are adding more and more records, that's why sometimes purging also helps, right? It helps to reduce the depth, right? So in case of secondary indexes, the difference is it doesn't sort the records or actual data page files according to the index, right? Instead, it has links to where actually this records has, right? So in this case, now in the same data set, now we have a primary key based on the ID based on ID, this one, and we have second index based on name. Now we cannot sort the page files because those are already sorted because of the primary key. Now what we have here is the second index based on the name, and these page files is similar. The arrangement is similar to the normal primary key, but it has direct links where actual records can be found. Right? So in this case also, if you run a query like where find the name equal something like that, it starts from the root node and go in the same process, and from there it identifies where actually this record is and directly access the page files and read it. Right? Clear? Any question up to this point? Right. So don't worry, we'll be jumping into exercise very soon. You guys feel sleepy? Don't worry. Okay. Before jumping into exercise, one more thing that I want to cover is dynamic and static data formats. So basically, dynamic, the main difference is now you see now you have need of having storing large text files or images or let's say large data. So if we have them, if we compromise, you might not read those fields every time as well. If we store them in the main page file, every time, regardless of whether you need it or not, you have to read that data point as well, which reduces the performance because it has to perform a lot of I/O operations. Right? Instead, normally these dynamic data or large data types have a reference to the actual data in the main page file. Basically, if you store a varchar field, it's storing two page files. Right? The first main page file will have subset of data plus reference to the actual data file where actual data is. Right? If you don't need that data in the select, actually you don't have to read that page files as well, which means eventually you can embed a lot of records into the main page file because you don't have those data. And if you don't really don't need those fields, you can just ignore those I/O. Right? From that, you can optimize the I/O performance of a data. So basically, we consider varchar, var binary, blob, and text as dynamic data, where only the pointer will be stored in the main data page file, whereas other data types are stored in the main page file. Right? The difference is if you run a select all, this will have to read lot of I/O, and this will this don't have any difference because anyway it has to go through all the data files. Right? So any question up to this point? From this point onwards, we will be jumping into the exercises, and you will have to use these things that we have learned sometimes to fulfill those exercises. Any question, if there's any unclear area or anything that you are not sure about, you can ask questions, and Saju also will be there to help. And this exercise, we want you to do it here as much as possible so that we can help to identify the mistake that you guys have done and teach how to do. Any questions? Okay, so let's jump into the first exercise then. So hope everyone has restored the database. So this is what you want to do, right? First, this is a simple database which has kind of a store and the store sales data. I want you to write a query to get the total sales of the store. This is the store ID for the year 2019, right? And then first I want you to try this without any database optimization and calculate the number of seeks it has to it has to be done to fulfill that request, right? Page files, basically number of page files it has to read, right? Then I want you to optimize this query by applying indexes or whatever way that you can to reduce that one, right? So there are hints. So first thing is the timestamps of this are stored in as timestamp or Unix times, and there are a couple of functions that you can use to help this thing, right? Okay, so any clarification of this exercise? This is a simple exercise actually. Query is very simple. Rest of the stuff you might have to learn certain stuff to do. Right? Okay, shall we start? Let's look at how we can do that. So I think most of you have done part 1 and 2. The query and the seek calculation. But I think you are struggling with the second part, which is the most important part actually. So let's jump into that part. Do you need any help of section A especially? That is quite straightforward, right? What we have to do is you have to, let's say, assume you wrote the query. Now if you have the query, but you have to run the expand command, which gives you the expected amount of expected number of rows will be analyzed, kind of estimate. Then from information schema you can get the average row size, and from system variables you can get the page file size. What we have to calculate is how many records that a page can store, and divided by the number of records can be analyzed. So which is eventually gives you number of IOs has to perform to fulfill this query. So which means that execution engine has to go to hard disk or whatever the caching mechanism that we have to get data that many times, right? Which is the slowest media. If you get 10,000 times, it has to access hard disk 10,000 times. It's not a small number. Since nowadays hardware are fast, you don't feel it. But if you think of a billions of rows, which will be considerable time. So you have to make sure you spend least amount of time of accessing hard disk, right? So which is straightforward. Now let's jump into the section B and see what we can do. And now first of all, I got a query from one of you, and let's see how it works. This is a query that I got from one of you. So what it do is like select sum of total from ticket table where ISO ID is something, and it gets the year from the created time which it has from the created time field, right? So what I can do to optimize this one, right? First I can do, let's execute this one and see. So it's basically analyzed about 791,540 records according to my database to fulfill this record. So first thing that I can do is I can create an index and see whether it's working well, right? So since it has two columns, I can it needs to filter for both created time as well as store ID, and I'm going to create a multi-column index and see what's going to happen, right? So let me create an index and see. Maybe I can copy part of that one. Okay, the index first and see what happens. Okay. I'm going to create an index on ticket table from both created time and store ID, right? Whether this index is correct or wrong, that's a separate question. Let's see how it works and see whether is there any other way that we can optimize index as well. First, I'm going to create this index. Right. Now, index is created. Now we have a query which compares created time and the store ID, and the index also there. Now we are expecting that to be work, right? But I don't think it will work. I'll explain why. Let's see how. So still it's analyzed all the records. Right. Even though we have an index on both the columns, it doesn't use any index. Even if you see the possible keys, it doesn't even care about the index that we have. Right? It doesn't even think. So any guess why it is that? Right. Any answer? Any guess? Sorry?
Because created time is different. It's different. So for each row,
Created time different in the sense.
milliseconds.
Okay. Yeah, that is anyway there. That is not the main reason that why this index is not applied. Yeah. Yeah. Yeah, that is exactly the correct answer, right? What happens here is, now if you see, we have applied a function on top of created date, right? The index that we have on the created date. What happens here is now something like that, right? You add a calculation on top of an existing value, right? So if you remember the indexing storage, let's say something like this. Now we have set of page files there. Can you see it? Hello. No, wait a minute. So we have set of page files and the index files. We have links like this. Now here we have 1, 2, 3. Here we have 1. Here we have 1, and so something like this. Right? This is the index column. If you run a query, select the records where whatever ID equal 1, it can traverse to this one. But if you apply a function, let's say fn ID, which gives output, let's say this function multiplies by 100, right? It gives output as 100. So where you can find 100 in the system? Basically, it cannot find. So that's why if you once you apply a function on top of an column, regardless of there is an index, it cannot use because it cannot decide what's the desired output of the column, because of that it simply ignores. Right? So remember, that's one of the key things to remember. If you are working on a query, if you try to filter it from a warehouse, don't apply a function on top of a column, because you never be able to optimize, or you never be able to use indexes, which means over the time you will end up with situation like this. This table has million rows. It has to scan through million rows no matter what, because it cannot identify the index. So how we can change this to utilize an index, right? Or how we can remove the function from the column, right? So there are two options, right? What we do is actually now let's say you run a query, you say field equal x, right? This is the column, this is the variable or parameter. Now what we have done is, you have applied function on top of this one, right? Instead of doing that, what you can do is, you can apply the logic, opposite of that logic, on top of this one. This is the parameter or static value that we are passing. Right? Let's say instead of kind of multiplying the column by 100, if you can divide the parameter by 100, still you get the same value. If you divide this by 100, you will get 1. Then you can exactly find where 1 is. Right? So it can replace the function. It's a simple thing. We just have to apply the opposite of the logic as a function, whatever calculation logic, on the parameter, not on the field. Right? Clear? Okay. Now let's change the query accordingly and see what happens. Okay. So this is the modified query. So we have done the opposite, right? Instead of getting the year or converting Unix time into a date time and extracting year out of that, what we have done is actually convert or get the Unix time stamp from a date field and run a between column. So what this gives is actually get the millisecond value of this date and this date, and both we get millisecond values and run on top of the created date field, right? Which doesn't have any function now. Now, ideally, this should run. This should apply the index, right? Am I correct? Right? Sure, right? You sure, right? This should run perfectly now. Let's see. Ideally, this should not. See, now it starts seeing the index. There's an index like that, but it's ignored it. So if you see the key which is being used, it is null. Even though there's an index, it has ignored it. It still go for 79,000, right? So now we don't have any function applied on the top of column. We have the index, but still it's not being used. So these are the problems that you will see in day-to-day life. When you dealing with the database, and when the database is growing, you have the index, it's not being used. So why? So any guess? Okay, let's have that one. But we can say this to ID should have coordination. Right? Still not. There's no difference. Why? Any guess? So let's try it for a shorter period of time whether there's any issue. It's being used. If we try it for a shorter period of time, now the index is applied, right? So why is that? So you will come across this kind of situation when you are dealing with. What you can see is now there's an index, it's previously been used, now suddenly it's not being used. Now out of the blue, what the hell can happen? Right? So why is that? You have to know why is that happening, otherwise there will be magical things happening in the database, you will not know, and over the time you will have to face to a time bomb. These are the time bombs. Right? For now it will work perfectly. 5 years down the line it will be blown up. So if you know why it's happening, it's very easy to fix. So those are things actually we want to explain, or we want to give the knowledge. Any guess? Yeah, that is kind of, why is that? Yeah, that is correct. So now that is where the data cardinality comes into picture, right? So now in this case, what we have done is, we have the first column, we have selected the created date, then the store ID, right? So what happens here is when you have a multi-column index, so it tries to narrow down the record set from the where clause as much as best it can, right? So if we create index in this way, first it try to identify all the rows which are in 2019. Which means in this case majority of the stores are created on 2019, right? So almost all the rows are in 2019. So no, even you have the index, why do we need to apply the complex logics of calculating indexes, because all the rows are in 2019, not be useless, right? So because of that, decide to ignore it, because all the rows, even though you ignore the index, you have to analyze all the rows because all are in 2019. Right? You cannot narrow down the records based on the fields that you have in the order. And remember, the order of the index also matters. That's how you narrow down the records. Right? So that's the main reason. That's why it doesn't work for if you put a large period of time. For the year, it doesn't work. Right? But if you put a 1 month of range, it works. The reason is it can narrow down. It's just 1/12 of the records. Right? So then it worth to analyze the index or worth to read the index. Right? So that's why it's happening. Right? So as Lahiru mentioned, if you swap the columns, what happens is first is try to narrow down to a shop. If you have 1000 shops or stores in the record set, is in the first run it can narrow down the records by 1000 times. Then second column, then out of that 1000 you can narrow down up to again another small set of data. That's a data set only that you have to read. Right? That's what the order. That's why the order is. It's not any order that you can think of. You have to think of the queries. You have to analyze the data, and you have to analyze the queries. What are the requirements that we have, and decide what are the indexes that we have to apply based on the filtration that we have to create. Right? Clear? Okay. Now let's swap the columns and see how it works. Now this should work, right? Since we have separate. Still not. Why is that? You don't speak. Now we swap the columns as last dimension. Now it can narrow down, and everything is in the correct order. Still, index is not being used. Right. So what will you do if you face such a problem in the production environment? Yeah. So if you analyze the table, right? So let's say what's there in the table. So store ID is a varchar column, right? And what we are passing here is actually an integer, right? So what happens here is it actually does an implicit typecasting on top of this one to convert this integer into a string. What that just mean is actually even we don't see it, it's apply a function on top of this ID. Basically it has a cast function on top of this one, right? If you apply a function on top of it, what will happen is this thing, right? So it can't use the indexes, right? Okay, so now if we pass this as a string or whatever, the varchar column, then it should work. See. See, now everything is in correct order. You just have to analyze 11,000 records to fulfill this kind of query. So if you remember, we initially it was around 700,000 or 800,000 records. With this one, to get the same record result, you just have to analyze 11,000 records, right? So which will run very fast. So if you enable profiling and see, you can see what are the things going internally as well. Right? Any question up to this point? Anything?
Tickets, it is store ID, this time period, it's around 6,000. So if you have a proper index, it should only go through 6,000 records. Now it is going to 11,000.
Yeah, good question. So what he's asking is now in the store it has around 6,000 records, but here it has to analyze go through 11,000. So this is actually not actual number of records. First thing is this is an estimated number based on the stats that it has on the metadata. So which may wrong as well because it's not getting updated always. Time to time it updates the metadata. This is kind of estimated number. Right. Also, this includes all additional record. Even though record has this much of record number of records, page files might have certain other additional. As you remember, if you hit a page file, you cannot jump into the exact record from that point. Right. It has to read from the beginning. Right. So which means it even you don't get as a result, it has to go through these records. So that also taken into consideration. Right. So eventually number of records needs to be analyzed to fulfill this query actually higher than the number of actual records. Right. Any other questions? Clear? All clear? Because we are going to jump into next exercise. Any questions? Anything? All clear? Because very important to understand these things because those are the things that we will face in the future.
Maybe,
Yes, we can. There is no limit as far as I know. But the issue is now, once when you have more and more indexes, every time you insert a record, it has to update indexes as well. It has to update their B plus trees and everything. So eventually, insert getting slow, also deletes, right? And other thing is for this particular query, if you have multiple index, it cannot use, because for a table, it can use only one index for a given query. Even if you have multiple index, it cannot use. So based on the queries that you have, you can create indexes. So better to identify what are the multi-column indexes and apply them, because now since we have this index on store ID and the date, this index can be used to filter or run a query without date or only with the store ID as well. Still this index will be used because it can narrow down the record. So for example, if we delete entire this section, so still this index can be utilized. So you don't have to have multiple index. So in this case, you don't have to have separate index only on store ID, because this index can fulfill that request as well. See, so it can fulfill both queries with only with store ID as well as store and created date. Right. Okay. So now, so far, these are things that we have learned. Right? So now we learned about how the execution work, how the query is getting executed in the database, and how the data is stored, how the indexes are stored, and everything, and how to analyze the query plan and how to create an index, and basically based on these results, how to identify or optimize the query as well as the index in the database as well. Up to so far that we have learned, and we have learned about what happens if we apply a function on top of a column, and what is implicit typecasting. What happens if you don't consider about data types that the table has when you are querying the data. So those things that we have learned, and again, we have learned the cardinality, how it is impact, right? When selecting column mode, right? How it matters over the time, how it can be result into a kind of time bomb situation. So make sure you actually learn those things and apply those things in day-to-day work. Otherwise, those you will have to face these consequences in the future, not in the near future, maybe 2 or 3 years down the line. Right? So make sure you learn, and if you have any unclear area on this one, make sure you ask questions, because these are the things that we have learned in hard ways, doing so many mistakes, having so many production issues, right? So we struggle a lot to learn those things, right? So make sure you gain maximum as much as you can, right, to learn those things, because we don't want you to do same mistakes, and we don't want you to struggle on these situations, right? So make sure you learn these things. Okay, so next exercise again is purely on query optimization. So I just want you to optimize this query, right? So there are 2 functions in the data. Ideally it should have. If it is not there, so you have shared it in the Slack channel, right? Yeah. So yeah, if these functions are not there, just get those functions and create them in the database and see whether the query is working. I'll put the query there as well, so that you don't have to write it again. as I explained, we have 3 data sets, right? So how we can derive those 3 data sets, right? So basically, this. Okay, so so what is the first data set? It is all this stuff, right? Simple. First data is set is done. Now what is the second data set? Right. This is online ordering enabled set of merchants. Right. So as I told earlier, if we do a inner join, it gives the intersection. But here we don't need, what we need is, if shop doesn't have anything enabled, we need that row as well. Which means left or right or whatever outer joins gives you the particular output. Right? So then obviously the second join is a left join or right join. So let's do the left join. From where? It is from store settings. Store settings. Says T1. Okay. On. I'm joining. The previous one is set s dot id equals and what I need is as this data set online ordering enable operator. So I can have another field and the setting key is value enable. Right. So what I need is s.id, then s.name, then so here since it is a left join, we don't expect all the rows in the store table have corresponding matching row, which means that can be null. If a particular store has online ordering enabled only, we get a record in the second table. Rest stores we get null. So what we need is kind of a false. We can do it by checking null. So we can simply do it by using something like this. What I do is, if the value is null, get false because there's no record for that particular merchant, which means it's not anything. If there is any value, it can be false or true. Still, we can get same value. So we get this whatever value available in settings. Now we get online ordering enabled data. Now we have 22 data sets. Now we are going the third data set. Similar. Only the setting key is ordered here. That's all. Either this will give you the same record set. And if you see the profile, only 3 times. You just have to check the partition 3 times for the 3 join and 1 execute and send in there. Everything is decided. Earlier you have noticed so many executing and sending there, executing and sending there. It is decided now. You don't have to execute it multiple times. It's just a matter of changing the way of thinking. Right? So, when you are doing programming, it's tend to think in kind of procedure. Do a certain step, then next step, then next step. In here you have to change your thinking pattern, and you have to think from the data set perspective and always think of how to join those. Right? Clear? Any question? This is the expected answer. Any question? Any clarification? Any clear? 100% clear? Okay. Right. So yeah. Now. So with this exercise, actually what we have learned is actually now if we use functions, use a defined function in this way, how it affect the performance, right? So basically it runs over and over again. It's actually ended up with having a lot of I/O. Right? So then how you change your mindset from programming to the database, because that is also really important, because you have to deal with databases day to day. And then usage of set operations. How you use set operations, which you have learned on, let's say, 10, 12 years ago, to solve these kind of problems. Right? So next topic that we are going to discuss is, I don't think we have enough time to cover, but let's try to at least kind of briefly touch upon these things. This is a kind of big exercise actually, which is based on actually ETL writing. Why we thought of doing this is actually every day you have to work with some sort of ETL. If you are working on a system, you might have to migrate data from some system to other system, right? Maybe continuous, maybe one time, right? It's not necessary to be a huge ETL. You don't have to be a data warehouse developer, but someday in the life you have to do this kind of work. You might not know this is an ETL, but actually you are writing an ETL. Basically, ETL is extract, transform, and load, right? So whenever you do that, it's an ETL. So when you are doing or writing an ETL, there are certain things that you have to be aware. It's not about SQLs. It's again thinking pattern that we are going to discuss, right? How you model an ETL which scales well, or kind of runs, or you can plan, or you can predict, right? So this is the way. I don't think we can complete this example, but at least let's try to cover the concepts or the thought process as much as possible, so that you can try it out. So I'm not going to teach any of ETL development tool or technology. It is just the just I want to change or give how you should think in terms of ETL. Alright. So this is the exercise. Right. So now you have seen that there is a table called daily sales summary. Right. We need to write a simple script or job or whatever to populate this particular table. It is not a simple script. It should be scalable. You should be able to plan. Let's say if you run this particular job in 5 years in the future, it should run, or you should be able to predict it. This is the amount of hardware that you should do, and you should be able to scale. And of course, you have to think of, now it takes weeks to execute, or maybe it might take a couple of hours to complete that one. It may break in the middle. Anything can go wrong, right, when you are doing things. So what happens if it goes down in the middle? How you recover from that point, right? So those angles that we have to think, right? So just spend 10-15 minutes and discuss how you think you are going to implement this job. Right? Try to utilize any programming language if possible to implement this one in the future. But more importantly, is how you plan or how you design this kind of a job, because if you run bad queries, so if you run kind of bad practices on top of it, eventually impact the database as well. If you run huge queries, it might block entire database for a long time. So it will block all other operations in the application. So you have to think those things. That's why this profiling and all we discussed earlier. You have to think of how long the database get logged, how long the table get logged, how long it will take to execute those things. Everything you have to think, because this is a highly concurrent system, right? It's not only your query running on the database system. There are so many clients are accessing the database system, so many requests needs to be fulfilled. You have to be aware of all these things. Without breaking these things, how you design such a job, that's the challenge. Right? So this is just to think how you are going to do this. So just spend 10 minutes and think how we are going to plan this one. And let's discuss afterwards about 10 minutes, because I don't think, actually I was expecting to do this exercise in the class as well, but I don't think we have enough time. So just let's try to think how we can do that. Kokulan, if we are to implement this job, how we are going to implement? What's the approach? How we are going to? So basically, this is the requirement, right? You have to populate this table. Whatever your task should scale, also should be predictable. If there is any failure, you have to recover from there. So how do you design your ATL job? What's your approach? Okay. Okay. So now, a small question. Now, the expectation is you have to run this job on top of this table, this database, and update this table. Now, this database has 5 years worth of data. So, how do you process the historical data? Do you have to update each and every row? Or? Okay. So basically, what you are doing is you are designing 2 jobs. First is actually thinking of stream processing each and every update we are going to aggregate it. Other one is batch one. So how do you write the batch job? Let's say this has 1 billion records. So how do you write this? Now you came up with a job. Now if I ask how long it will take to execute, how do you tell I need this many resources, this many hard servers? How do you calculate? Okay. Yeah. Yeah. Yeah, somewhat correct. Right? Now, what we are saying is basically you have to identify chunks, right? So, if you know the time to execute or process that particular chunk, then we have to multiply this number of chunks. In this example, what is this chunk? In your view, what is this chunk? Because that particular chunk should have predictable amount of records. Then only you can predict number of chunks that we can process. So what's your chunk size? How you chunk your data? There are multiple ways. There is no right or wrong answer. Now, as you said, the fundamental is you have to chunk the data and you have to process these chunks in parallel. If you know the time which it takes to process a particular chunk, then and the resources to process that particular chunk, it's just a matter of parallelize that particular process, and based on the number of chunks available in the system, you can, it's simple mathematics, right? So you just calculate it. Now, what is the chunk? So that's the question. So there are ways. So, okay. Now one way is what we are saying is you are running it daily. So particular iteration, particular chunk, you get the records created within that particular day. Is that a fixed chunk? Right. So let's say now we have 1,100 stores in the system. So 5 years down the line, there can be 50,000 stores which generates 5 million records a day. Right? How do you predict that one? You can't, right? Because chunk size is dynamic. You cannot allocate resources. You cannot predict the time. Right? So then we have to have another way. So any other thought? Miru? Data set. Okay, so now what will happen is when you are selecting predefined set of database set, now this table contains daily summary of a particular merchant or store, right? So let's say you select the chunk size as 1,000. If there is an operator or a store which does 2,000 orders a day, how do you update that particular record? Because only one record which doesn't have any information about the rows which has already aggregated. Right? How do you make sure you don't duplicate or you don't reprocess the same chunk again? Because otherwise, it will end up with having incorrect values because you will update the same value. You cannot simply adapt. That's why you have to make sure it will recover correctly from the failures as well. Right? That is somewhat correct, but there are ways. So there are complicated ways of recovering from that one, but you can do that as well. But is there any other different, simple way of doing that? So this is the first thing that we have to do right now. When you get this kind of solution, you have to analyze what are the data that you have, right? And see, you might have to try different approaches, you do certain studies, and see how you chunk these kind of data in a kind of predictable manner. There are ways by looking at the data set. It's just a matter of trying it out and see the behaviors and all, and identify certain patterns that you can identify those kind of chunks based on the business domain as well. It's not quite difficult. It's just a matter of we don't think of that one. Any other answer? People in the back? No. No answer? Okay, so what if, let's say, Kokulan said you can chunk it by day, right? So what if we chunk the data, let's say day worth of data for a store. That is our chunk, right? Let's say food city, Kavis food city in, let's say, Columbia, right? It is highly unlikely that to kind of increase the number of orders that you do in a day in 5 years also. Right? Let's say if you are doing 1,000 orders a day on that particular location, maybe in 5 years it might do 1,200, because there's a capacity that particular location can have. Right? It's very highly unlikely that get changed. Right? If you distribute that chunk across multiple sets, right? So then let's say it is average is came up to about 1,000 records. A store does 1,000 records a day in average. So it's just a matter of in the future how many restaurants are there or how many stores are there, and calculate it by average. You can simply allocate these resources. So what matters is actually all the time you have to think a chunk which doesn't get changed or change a very little, right? Then only you can plan these kind of jobs, right? Then the query is also simple, because you always know to fulfill this particular chunk, you have to accept, you always know this is the time taken to execute this kind of query. It's just 1 day worth of data for this particular store, right? It's always, you remember the first query that we tried. It's multiples of that query. Right? It's highly unlikely. The predicted amount of records is very limited. Right? The query, most likely the query will perform in the same way even in the future. The example that to say first, if you don't consider operator, what will happen is it is this cardinal issue. Right? Today we will have 1,000 records, so 1 million records per day. 5 years down the line it will have 10 millions. Then suddenly index might not be working. Right. So it's important that you think of those angles. By analyzing a data set, you have to decide what is the chunk size. Then you can have different approach, maybe a log, to log what are the successful chunks. Next time you can start from there. All right. Clear? So just try it out in a certain programming language. It's very easy. So basically, let's say if you kind of allocate a thread to process a chunk, then you can simply calculate how many threads that you can allocate to process this much of chunk. And if you get the time, let's say to process a chunk it takes 1 minute, and if you have 10 chunks, if you have to process all these 10 chunks in 1 minute, you just have to allocate 10 threads. Otherwise it will take 10 minutes. Right? It's simple mathematics, so you can simply predict. Even in 5 years down the line, you can simply predict what is the hardware resource that you need and time taken to. So those are the lot of challenges that you are facing. You might write those jobs, ETS and all. You might write it today, and it might not run in the future, because we had similar experience, right? We learned from those things. Earlier, we had to write an ETL job to do similar operation, right? Initially, what we had to do is we had to daily update particular summary table. Initially, it took 2 hours to run this particular daily job, right? Couple of months later, not even years, let's say 3 or 4 months later, to process 1 worth of data, it took 36 hours, right? Which means to process 24 hours worth of data, it takes more than 24 hours, which means it's never getting finished, right? So this is very unpredictable if we are unable to predict the chunk size. If we have done that in this way, we just have to increase the hardware resources accordingly. Right? If you want to complete it within 1 hour or 2 hours, we could have simply scaled it. So those are things that you have to be aware of. You have to think and learn from because even we discuss here, you might not remember. That's why it's very important to try this exercise and see. It's not simple as we're discussing, right? We will have to face a lot of problems, and definitely we will have to work on these kind of projects all the time, because there can be projects you might be working on monolithic application, you might have to move it to a microservice, which means you might split the databases, which again requires this kind of ETL. It has to run. maybe your downtime is a limited downtime. You might have to migrate to entire database within 2 hours. Right? How do you predict? When you are developing, meanwhile database is growing. Those are the challenges that you have to face as engineers, right? Not only the database guys, right? As engineers, you have to think, because otherwise you will be too late when you are trying to execute those things in the production system. The deployment time, you will be too late. So you have to think of those angles. So that's about it actually. Now with this exercise, what we have tried to cover is basically how you identify or how do you partition data for this kind of process. What are the characteristics that you should have in a partition? Right. Then predictability. How you predict the resources and the time based on this partition. How you calculate it, and then how do you use multiple threads or multiple processes to process these particular chunks in parallel. So that's all. There are actually there are a lot actually in this, but this is what we thought of good to cover. So if you have any question, I mean, I can answer if you have anything. Any question? Yeah, that is also up to your job. You can decide now, since you know the chunks, you may use a log, right? To log whatever successful chunks, you can record these chunks are successful, so that you simply can ignore from that point. Or maybe you may use last process time. Whatever you can decide based on the logic. That's completely up to you. The reason that I made that as a point, since I forgot to mention, I mean, this solution doesn't came as a solution from you guys. If some might think you can kind of write a single SQL select insert query from the database. If it is fail, it will roll back, right? But the thing is, in this case, it doesn't work over the time. So relying only on the database, not a solution, which means you cannot rely on the rollback mechanism in the database, because it doesn't work as an atomic operation. So that, see, because of that, that concern comes as an application concern in the design concern. Right? You have to think different ways of handling failure required, because database no longer going to do it for you. Right? So yeah, that's the main reason actually. Any question? Anything? Okay, so thank you guys. Actually, we actually 15 minutes late as well. So thank you for your time, and hope you learn something and try to apply those things in your day-to-day life. And feel free to ask any question at any given point if you want to learn it. Okay, thank you.